Hello everyone. Today we are going to discuss the very important topic of class 6 from ICSE Board, fractions. And please don't mind that this is going to be a concept which you will be using throughout your life until unless you clear some exams and you get into a particular stream, for example medical or anything else. So it's a very important concept, though we will be covering as per class 6th, but we will try to cover as advanced as possible. So first of all, what we are going to cover in this is number 1, basic concepts of fractions. Number 2, representation of a fraction on a number line. Number 3 is type of fractions. Number 4, comparison between two fractions or more fractions obviously. 5th number, addition and subtraction of the fractions. 6th, multiplication and division of the fractions. Number 7, power and exponents. Number 8, a real life usage of fractions. So let's start with what is a fraction. So basically fraction is something of a whole, a part of a whole. Okay, so let's take a very simple example. You have one chapati or roti or Indian bread and you just cut into two halves because you want to distribute that chapati between two of your sons or daughters or brothers or two persons basically, right? So this part of one whole chapati will be represented as one part of how many parts are there now? 2. So this is basically one part, this part, the shaded part is one part from two parts. So this from a whole one chapati, you will call it as 1/2 or a half. So this is the fraction. Similarly, if we have, let's say, one bread, we cut into 3 pieces. So this particular piece will be known as 1/3 of the whole bread. And if someone asks you that, okay, if you give this 1/3 of a bread to someone, how many pieces or how much bread is left? So that is 2/3, right? Because these are 2/3. As a whole, it's 3, but out of this, one has been already been given, so 2 parts. So basically, this is a representation of a fraction, and as you see, it's very basic, very simple. You just need to get into the basic of this from this particular example. Okay, now let's move on to the second part, that is representation of fraction on a number line. So listen very carefully. For example, if we have a number line here where we put 1, 2, 3, 4 and 5. Let's say this is a number line and it extends there and here as well. Negative numbers you will learn later on. This is 0, right? From 0 to 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5 and so on. So where exactly you will find these fractions? So prima facie, first time if you look at this, you will not find anything else. But when you zoom in, you will see something is happening. So assume you have I have given you some superpowers and you can just get into this deeper and deeper. So what will happen here is 0, 1. Let's say we put some mirror here and we just enlarge this. So these points of the number line 1 and 2. If we say we need to find that, okay, what is the first fraction of this? So there can be multiple thousands and millions and trillions of fractions can be here. But to understand this, first fraction, which is very common, that is half, the midway of these two numbers. First fraction you will find here is between 1 and 2 is 1/2. Okay. Now, if I tell you, if I ask you basically, what is the fraction, what is the most common fraction you can find between 1 and half? There can be many obviously. So we'll divide this into this whole. We consider this as a whole. Now we further half it, right? We reduce it to half, then this will be 1/4. So this will be again one more fraction you will find here. Now the half between half and 2 is 3/4. Right? So these are the fractions which you represent here. So basically what we have done is From here to here, this is one number. Let's assume that this is 1. Okay. And now we have divided this into 4 parts. So this is 1 by 4, this is 1 by 4, this is 1 by 4, this is 1 by 4. So this particular line we call it as 1 by 4. This we can call it as 2 by 4. This we'll call it as 3 by 4. And this we call it as 4 by 4. Considering this is 1 and this is 0. So now if you divide this one whole in 4 parts, you will get 1 by 4, 2 by 4, 3 by 4 and 4 by 4. 2 by 4 obviously if we simplify this will become 1 by 2. So we'll see it later when we have different calculations on fractions. So this is how you take it, right? This is how you draw fractions between certain numbers. Assume that, okay, this is again one bigger picture of 0 to 1, right? Now we want to divide this into 10 parts. Now we want to represent in fractions. So this will be very simple, 10 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, please excuse me for that. I mean, this is not equally distributed, so it's okay. So first part will be 1 by 10, this will be 2 by 10, this part will be 3 by 10, this will be 4 by 10, this will be 5 by 10, this will be 6 by 10, this will be 7 by 10, this will be 8 by 10, this will be 9 by 10 and this will be 10 by 10, or we call it as 1. This 5 by 10 will be 1 by 2. This is the halfway between these 3 numbers. So basically whatever fraction you want to calculate, you can divide that whole line into those many parts, and each part will be 1 by 2, 1 by x, 2 by x, 3 by x, 4 by x and so on. Okay, so this is how you divide this. So again, coming back to the basics, if we want to divide numbers between 0 and 1 in 2 halves, then 2 parts obviously, one part is here, one part is here, first part, second part, 1 by 2, then 2 by 2, that is 1. Then if we want to divide this into 3 parts between 0 and 1, then 1, 2, this will be the third part, right? 1, 2, 3. Calculate like this, 1, 2 and 3. So this will be 1 by 3, 2 by 3 and 3 by 3, right? Similarly, between 0 to 1, if we want to calculate, let's say 8 times, then 1, 2, 3, 4, 5, 6, 7 and 8. Then 1 part, second part, third part, fourth part, fifth part, sixth part, seventh part and 8 part. So this will be 1 by 8, 2 by 8, right? Similarly, this will be 8 by 8 and this will be 7 by 8. So as you can see, we can have multiple numbers between 0 and 1, and all these will be known as fractions. So this is the representation of fraction on a number line. I hope this is very much clear to you. Thank you. Now we'll be moving on to the next part, that is type of fractions. So types are basically very simple to remember. Let me tell you how easy to remember types are. Trick is to remember P, M, and in between P and M, I put I. Simple. P is what? P is, yes. So to remember this, it is very simple. P for proper, I for improper, M for mixed, right? Proper fraction are those fractions which are less than 1. For example, 1 by 7, 8 by 9. Basically, this denominator is greater than numerator. Fine. So this is how you have proper fractions. Then this is improper fraction. In improper fraction, you always have numerator greater than denominator. Okay, 7 by 6, 8 by 11, 18 by 11, 20 by 3 and so on. There can be a number of fractions. Mixed fractions are fractions which are mixed basically. So we have a whole number, let's say 6, then we have some part here, right? Like 6 by 2 by 3, 7, 3 by 9 and so on, right? So these are mixed fractions where we have one whole number and another one is proper fraction. So a mix is nothing but a mix of proper fraction, okay, but it will be followed by a whole number. So this is how you represent mixed fractions. And mixed fractions, if you simplify these fractions, this will be 16, 20, 18 plus 2, 20, 20 by 3. So mixed fractions basically are nothing but improper fractions. So you can convert improper fraction into mixed fraction and mixed fraction into improper fraction. Formula is very simple. If it is 6, 2 by 3, then you first multiply this number with this number, then add this number. 3 6 are 18 plus 2, 20, 20 by 3. Okay. So as you can see that proper fractions are basically, in short, less than 1 numbers. These are proper fractions because these are not a whole more than 1, right? Improper fractions are always greater than 1 because numerator is going to be greater than denominator, and mixed fractions are nothing but it's a mix of two things. First part is whole number, second part is proper fractions. So I hope this is also clear. Now quickly we will check how we can convert improper fractions into mixed fractions and vice versa. How we can do that? So it's very simple. Let's say we have 20 by 3 and we want to convert this into mixed fractions. So what we'll do is we'll just divide this with this. So 3, 6 are 18 and remainder is 2. So we'll write 6, 2 by 3. Very simple. So 6 will be here, is the whole number or natural number you can say, then 2 by 3, remainder will go here, question will be going here. Okay, so this is how you convert an improper fraction into a mixed one. And to reverse this, as I told you earlier also, it is just multiplication of these two numbers, and then adding this will give you the improper fraction. For example, 6 3 18 plus 2 20 by 3. So I hope this is also clear. Now there are two types of fractions, that is like fractions and unlike fractions. Like fractions are nothing but the fractions those have same denominator, right? For example, it's 1 by 7, 2 by 7, 3 by 7, all are like fractions. So other examples can be 8 by 11, 10 by 11, right? So these will be like fractions. Similarly, this value can change, that is numerator can change, but denominator will remain same in like fractions. In unlike fractions, obviously, these will not be same. So you can, just for the definition purpose, you need to remember like, all the likes, that is denominator is all similar, and unlike denominators are all different. Now the very interesting part which we'll be discussing here is equivalent fractions. Equivalent fractions are nothing but, as I told you, equivalent fractions. Sorry for this thing. You need to focus more here. So equivalent fractions basically are nothing but fractions that are equal, values equal. For example, if I say, okay, I have one chocolate, I'll give it to two people, that is half, each of them will get half, right? Now I have two chocolates, one here and one here, and I'll give it to 4 people. Obviously what I'll do, I'll cut this here, I'll cut this here and provide to everyone, right? So this will be half, half, half and half. So, or we can say that this is 2 by 4. So basically, if we multiply any number to the numerator and denominator, they will result in equivalent fractions. For example, if I multiply with 2, this will be 2 by 4. If I multiply 3, this will be 3 by 6. If I multiply with 4, this will be 4 by 8 and so on. So all these fractions are actually meaning the same, that is equivalent. These are all equivalent. So these are known as equivalent fractions. Now the question comes, how we can find whether the two fractions are equivalent, right? Here we'll understand the concept of cancellation, cancelling the commons or cancelling the prime part of it. For example, let's say 1 by 2 is equivalent to 8 by 16. How we can find that? What we'll do is we'll just, we'll apply cancellation method. Here what we'll do is, there are multiple methods which we'll be learning later on. But here, for example, we can say that it's 8 into 1 multiplied by 8 into 2. So we'll cancel 8 and 8 because these are similar thing, that it's a whole, 8 by 8 is a whole. So 8, 8, 8 cancel and we get 1 by 2. So this is how you calculate, or you just find out whether two fractions, these two fractions, 1 by 2 and 8 by 16, whether they are equivalent or not. So here we'll be cancelling using multiplication method, and we'll be using prime factorization later on to decide whether two fractions are equal or not. So these is nothing but equivalent fractions, the method to find whether two fractions are equivalent or not. Now one more concept comes, and that is reducing a fraction into irreducible form. That is, you cannot reduce a fraction further. For a fraction to be in irreducible form, we have two methods. First method is known as SCF method, and another method is known as prime factorization method, right? So here what we'll do is, for example, we have, let's say, 7 and 14, and we want to reduce this further to an irreducible fraction. What we'll do is, we'll just find out the SCF of 7 and 14. So SCF of 7 and 14 is 7, so we'll write it as 7 into 1 by 7 into 2, that is 1 by 2, right? Highest common factor method. Very simple method. You need to find the SCF of both the numbers. You just mention SCF multiplied by the rest of the number, then again the break this denominator into two halves, two parts. First one will be the SCF and second part will be the rest of the number. So the SCF and SCF will be cancellation method will be applied, and those will be getting cancelled, and we'll get the irreducible fraction. Okay, so this is how you imply SCF method. Now very similar method is your prime factorization method, where what we'll do is, we'll just write all the prime factors of a particular number in the numerator, as well as for the denominator we'll be writing all the prime factors, and then we'll be we'll be applying cancellation method, and we'll be cancelling all those things. For example, let's assume 9 by 27. So what we'll do is, it's like 3 and 3. Here we're writing 3, okay, not here, 3 multiplied by 3 multiplied by 3. So here 3 will be cancelled, 3 will be cancelled, and we'll be get 1 by 3. The rest will be 1, obviously. 3 into 3 into 1, 3 into 3 into 3 into 1. So 1 by 3. Okay. So this is how you'll be calculating. Fine. So here prime factorization method will be applicable, and we mostly use prime factorization methods later on, but you will not actually see what is happening. Let me give you an example. Let's assume that we say 2510 divide by 5590. So what we'll do is, for prime of AC, without thinking what we are doing, we just cancel 0 to 0. We are cancellation. What is happening is, we are cancelling 251 multiplied by 2 into 5, these two prime factors, divided by 559 multiplied by 2 into 5. Actually, cancellation is happening like this, but we always say, oh, 0 se 0 uda do. So actually we are not cancelling anything, 0 to 0. We are cancelling 2 into 5, that is 10 out of 10. Okay. Similarly, if we have two zeros, will be cancellation of both will happen. Ultimately, it will be a prime factors of 100. So combinedly, we'll be doing this. Here, I'll share a trick with you, though it's not recommended, but you should remember, whenever you see any 0 in numerator and denominator, just cancel it. Cancellation will be happening only when we have equal number of zeros. For example, if we have 2 zeros in numerator, 2 zeros in denominator, number can be anything, right? So will be cancellation of this will happen. For example, 500 divided by 20,000, right? 20,000. So only 2 zeros will be going with this. So we'll get 5 out of 5 and 200 here, right? So first you just cancel all the zeros, equal number of zeros. Actually, what we'll do is, what we are doing is, we are just cancelling 10 out of 10, right? 2 into 5, two prime factors from numerator and denominator each. Second thing you will do is, you just, if you see anything related to 5, right? 5 and zeros. We all know that these are prime factors of, this will be divided by 5, divisibility of 5, right? So let's say we have 50 and we have 25 here. So immediately just divide 5 into 5 will be there for sure, 5 into 10 will be there. So 5 out of 5, you get 10 by 5. Again, 5 into 2 and 5 into 1. So answer will be 2. So this is how you use prime factorization method. First you find prime factors. Now coming back to the basics, using expansion method. If we have, let's say, 20 and we have 196 here, so we'll write prime factors as 2 into 5, right? Here we will write 2, then we have 48, 2, 24, 2, 12, 2, 6, 2, 3 and 3, 3 to 6 to 12, 24, 48, 96. Okay, so this is how we'll write prime factors of 20 and 96, and then we'll start cancellation of equal numbers. 2, 2, 2, 2, 5 is not getting cancelled, so we'll write 5, 2 to the 4 to the 8, 3 at 12, 3 at 24, 5 out of 24. So 5 by 24 is the answer. So this is how you will use prime factorization method for reducing the fraction into irreducible form. Now we'll start with comparison of fractions. So comparison is, we always compare two things, right? You cannot compare apple with oranges and oranges with guavas. We always compare two equivalent things, right? So first thing will be, what is the concept is, first we try to convert both the fractions that need to be compared into equivalent fractions. For example, if we have 5 by 10 and 20 by, let's say, 50. If we start comparing this, then we try to convert into equal fractions, or let's say, the equivalent ones. So we'll reduce this further. This will be 1 by 2, this will be 2 by 5. Okay. So these are not equivalent, of course. So in this particular case, how we'll decide? So the general formula is very simple. First of all, if the numerator is same and denominator is different, and the other case can be numerator is different and 1 by d and n2 by d. Okay. So this can be the first case, this can be the second case. In this case, let's say 1 by 7 and 2 by 7. In this particular case, where denominator is same, here the number, the fraction which will have greater numerator, right, numerator, here the fraction which will have greater numerator will be the greater fraction. So in this case, 2 by 7 is greater. But in this particular case, it's just a reverse. If the numerators are same, for example, 2 by or 7 by 5 and 7 by 9. In this particular case, this will be obviously greater because this is smaller, right? So the reverse is there when we have different denominators and same numerators. So this is how you compare two different fractions, right? And the very common method, if we have, numerators are not same and denominators are not same, both the numbers are different, right? For example, it's 1 by 4 and 2 by 7. So it's very difficult to find, right, which will be the greater number. So to find the sign, let's assume it's question mark. What we'll do is, we'll multiply 7 into 1 and 4 into 2. So it will be, 7 will go here, so this will be 7, question mark will remain same, and 4 2s are 8, so 8. So which one is greater? So 8 is greater, right? 8 is greater and 7 is smaller. So here also the same sign will prevail and this will be greater. So 1 by 4 will be less than 2 by 7. I hope this is also clear. So let's take another example. Let's take 5 by 13 and 2 by 7. So don't put any mark, which one is greater, which one is lesser. You just put a question mark here, right? And start multiplying. 7 is going here, 13 is going there, keeping the sign same. So we'll keep the sign same. 7 is going here, 7 5s are 35, right? 13 is going here, so 13 2s are 26. Now, which one is greater? 35 is greater, so you just put greater sign here. So this is how it works. So 5 by 13 is greater than 2 by 7. Now the next part comes, that is subtraction and addition and subtraction of two fractions. So it's very simple. Let's assume two fractions are 2 by 8 and 3 by 7. How you will add these fractions? So these are not equivalent, right? These fractions are unequivalent. So to add unequivalent fractions, we take LCM method. LCM of 7 and 8, 56, right? Then 8 7s are 56, right? 7 2s are 14, plus 7 8s are 56, 8 3s are 24. This is how you do it. Now this is 448, 213, 38 by 56, and we further simplify this. 2 19s are 38, 2 28s are 56. This is the answer. Now if we have fractions with the same denominator, addition is very simple and subtraction is very simple. Let's say it's 5 by 7, we need to add 2 by 7, then keeping the denominator same, you just add these numerators. This is 7 by 7, or if you simplify this, this becomes 1. Similarly, if we want to subtract two fractions, 5 by 7 minus 1 by 7, then keeping the number same, denominator same, you just subtract this number from this number. 5 minus 1 is 4, so the answer will be 4 by 7. So this is how you do it. If the denominators are same, you just add or subtract numerators, and if both the numbers are different, then you just denominators are different, then you just multiply the denominators, or you take the LCM of those numbers and apply the method which we discussed. So this is how we do addition and subtraction. Now we'll start with multiplication of fractions, because from there division will be much easier. So to multiply two fractions, we have steps are, there's a process basically which we follow. So we have C, M, R, C. So in this we have C means conversion. So first thing we need to do is convert mixed fractions into improper fractions, right? Convert mixed to improper fractions. If you already have improper fractions, no need to convert, so you will disregard this particular step. Second thing is multiply. Multiply numerator with numerator and denominator with denominator, and then reduce it further using cancellation method. Reduce it further using cancellation, right? And last part is, this is again, both the C's are not compulsory, these are optional. Last part is convert the result into mixed fraction if it's asked. If it's not asked, leave it. So how we'll apply all these things, right? So let's take an example that we have 2 3 by 5 multiplied by 3 7 by 2. In this particular case, if you want multiplication of two fractions like this, we'll first convert these are mixed fractions, we'll convert these into improper fractions. So first one will be 5 2s are 10, 10 plus 3 13 by 5 multiplied by 3 2s are 6, 6 and 7 13, 13 by 2. And here to multiply these things, what we'll do is we'll multiply 13 into 13 divided by 5 into 2, right? Can we further reduce it into fractions? No, there is no cancellation because that is in a prime number. So we'll write it as 169 divided by 10. So this is will be the answer. If someone asks you that, okay, convert this into mixed fraction, then again what we'll do is 10 16s are 160 plus 9 16, 9 by 10 is the answer. So this is how you follow these 4 steps. Now we'll take another example. Let's say 5 by 10 plus 3 2 by 5. Here first thing will be converting. We'll be converting this one. No, this is the mixed one. So we'll convert this into improper fraction. This is already improper fraction. So first step will be 5 by 10 plus 5 3 is 15 plus 2 17 by 5. Right? So this will be the first step. Now here what we'll do is, will be this is not addition, this is subtraction, multiplication, sorry. So we'll be converting first, and then what we'll do is with multiply. So this will be 5 multiplied by 17, from here to here we are going, 10 multiplied by 5, right? And now we'll be checking whether we can reduce this into further, reduce this particular thing into further using cancellation. Yes, we can do that. 5 will go, will cancel each other, we'll have 17 by 10. So this is the answer. If in question it's been asked that you need to convert this into a mixed fraction, then this will be 10, 1, 7. 10 ones are 10, 7, 1, 7 by 10 is the answer. So this is how we multiply two fractions. And the very important thing is the word of. Of means multiplication. Okay. So if someone asks you 2 by 3rd of 18. So if you ask me the 2 by 3rd of 18, how we'll do is, we'll convert this of into multiplication sign, then it will be 2 by 3 of 18. So again, very simple, 2 multiplied by 18 divided by 3, then we'll reduce into 2 into 3 into 9, 3 into 6 divided by 3, 3, this will be 12. So this is how you will proceed with the multiplication. Of means multiplication. This is the first thing which you need to remember, because most of the times examiners just twist this multiplication with of. Another part that you need to, another word which you need to remember is reciprocal. Reciprocal is nothing but the reverse. For example, if we have 7 by 6, and the reciprocal of 7 by 6 will be 6 by 7. Very simple, right? So these two things will be used in fractions very frequently. So just remember these two things. Now coming back to our division. Division is nothing. If you are multiplying A with B, and if someone asks you, instead of multiplication, divide A by B, then what you need to do is, keeping A same, you need to multiply a reciprocal of B, that is 1 by B, with A, and that will be the answer. So let me give you an example, quick example. 5 by 3 multiplied by, divide by 3 by 7. How you will do that? Nothing. 5 by 3 will keep the first number same, multiplied by a reciprocal of 3 by 7, that will become 7 by 3. And now follow all the 4 steps which we have discussed, right? So this is how it works. And here the trick is, if examiner asks, okay, let me give you an example, 3 2 by 7 divided by 4 1 by 8. In this particular case, quickly convert the mixed fractions into improper fractions first, because then it will be easier you to calculate. It will be 7 3 21, 21 plus 2 23, 23 by 7 divisible by divided by 48 33 by 8. In this particular case, 23 by 7 multiplied by 8 divided by 33. Here we'll proceed. Okay, let's complete it. 23 multiplied by 8 and 7 multiplied by 33. Okay, I don't think this is going to be divided, so we'll keep the answer. 8 to 24, 4, 2 to 16, 18, 84 divided by 7, 21, 1, 2, and 21, 23. So this is going to be the answer. So it's very simple. You just, first you convert mixed fraction into improper fractions, then a reciprocal of the second one. Instead of divide, you change divide to multiplication, then reciprocal of this number, and then you proceed with the similar steps which we discussed. So this is how we divide two fractions. So powers and exponents, as I explained, there is nothing. Power means repeated things. For example, 2 raised to power 3, we will have 2 into 2 into 2. If this number changes into fraction, let's say 3 by 7 multiplied by 4, then this will be 3 by 7 multiplied by 3 by 7 multiplied by 3 by 7 and multiplied by 3 by 7, right? So this is how the repeated things can be written into form of powers and exponents. And if you have multiple powers and fractions in one equation, for example, it's 2 raised to power 2 multiplied by 4 raised to power 3, then how you'll write? Very simple, 2 raised to 2, 2 multiplied by 2, keeping the sign same, multiplication of 4 power 3, 4 into 4 into 4. You just simplify this and you'll get the answer of this. And the last part is real life usage. It's very simple, as I explained you earlier also, that fraction is nothing but a part of whole. So if someone asks you that you have a basket of oranges and someone takes out 3/7 of it, how many oranges are there, right? Or which particular part of fraction remains there. So we took out, let's say, 3/7 of this particular whole basket of fruits. It has several fruits. So what is the remaining fraction there? So this will be, whole is represented as always 1. 1 minus 3/7 we took out. So this will be again LCM of this. 1 can be written as 1/1. So 7. 7 minus 3, that is 4/7 is the answer. So basically in real life we have, as I explained earlier also, several examples are there. You divide things. When you divide things into two people, a same thing that cannot be divided, right? For example, a chapati, a fruit, a cake, a piece of biscuit, whatever. So in that particular case, fractions are used. I hope you got the concept, and if you have any questions or concerns, just drop a comment below and I'll try to answer that in the next video or in the answer itself. Hope this helps. Thank you.